Hi guys, I'm Lillian Pearson and I'm starting a vlog series. So my first topic is just going to be a basic introduction to big data, defining what big data is for those of you who do not know. And I thought it would be fun to set up the camera on the beach here because as well as being a data scientist and an engineer, I'm also a datapreneur, which allows me to live in different countries all around the world. And right now I'm living on the island of Koh Samui in Thailand. My house is right there, and so I thought, well, why not set it up on the beach so everyone can enjoy a kind of serene background as they learn about big data. Okay, to make it super simple, let me explain that big data is actually just data, but the velocity, volume, and variety is so great that it can't be handled and processed in a traditional relational database management system. And so that's a simple definition of big data. Just to get started, let me discuss the 4 criteria that make up the definition of big data. That's variety, velocity, volume, and value. I wanted to discuss first variety. In big data, we have structured, semi-structured, and unstructured data sources. Structured data is your traditional type of data. It comes from like transactional systems or web forms. It can be generated by humans or machines. But it's the kind of data we're all pretty much used to handling in simple relational database management systems. Semi-structured data, however, is data that comes in and it's not relational, but it's marked with tags, and so you can organize the data into hierarchies and work with the data according to those tags. Sources of unstructured data include log files, XML files, and JSON. And the last type of data that makes up big data sources is unstructured data. Unstructured data is the type of data that is either it's generated by machines or by humans. Common sources would be like emails or social media data. But basically, it's just data coming in from all different sources in no sort of order. Next, I want to talk about big data as it's defined by its velocity. And I made this little piece of paper here that shows you, okay, so here's like a criteria that you can use to evaluate whether or not your data set would actually, the velocity, according to the velocity criteria, would fall into big data, definition of big data. And we're looking at 30 kilobytes per second all the way up to 30 gigabytes per second. So the order of magnitude difference between these two is 1 million, and that's like a really wide window. The next criteria I want to discuss for big data sets is the volume criteria. And big data sets generally start at like 1 or 2 terabytes, and it's open-ended. So like starting at 1 or 2 terabytes up to who knows what. These are big data systems, and if you're working with data volumes that are that large, then you're probably working on a big data project. Another thing that's really interesting about big data volume is that it's pretty much increasing exponentially on a yearly basis. Just because of the changes in developments in technology, we have so many different types of new devices that can easily generate and capture data. So data volumes are really increasing, data velocities are increasing, and it's the data handling capabilities that limit our ability to create value from big data sets. And this brings me to the last criteria I wanted to discuss about big data, and that's the value criteria. And I just say that in and of itself, raw big data, the value is quite low. In order to generate valuable insights from big data, the data needs to be rolled up or boiled down into manageable size data sets, and then data scientists can come in and analyze the data and make interpretations in order to generate actionable insights that can be used to create value for your business or to achieve any other sort of goal that you're looking to achieve. And I'd also like to underscore here the difference between a data engineer and a data data scientist. And the data engineer is the person who comes in, probably a software engineer or a computer scientist, and they're able to take the raw big data and boil it down into manageable sized data sets. The data scientist is the person who comes in and works with that data set in order to extract actionable insights. So there is a key difference between data engineers and data scientists, but they both work to create value from raw big data sets. And the last thing I want to discuss about big data are some common sources. Sources can include traditional transactional systems, sensors like you get from, say, temperature sensors or motion sensors, or cameras, video cameras, social networks, Twitter, Facebook, the Internet of Things, and this is a whole nother concept of connected machinery, particularly mechanical systems, and so it's machine-generated data that's connected in a network, an intelligent network. So these are also generating big data sets, and another source would be things like clickstream data from when you go on the internet and you're clicking on different web pages. That data is actually tracked about where you clicked and where you went when you fill out web forms. So that's big data in a nutshell, and I hope that this shed a little bit of light on the topic for those of you who are just new to the data revolution. And thanks for joining me today. Alright, so I hope you enjoyed the first video, and I'd love to hear your comments, or both positive or negative. What are you interested in learning more about? Is the beach distracting you? What are your thoughts? I'd like to get to know more about you. So thanks for joining me, and I look forward to seeing you next time. Thanks.